senior lecturer at Swinburne, Sarawak. So a civil engineer by profession. I also a corporate and member of the Institution of Engineers Malaysia, IEM. So briefly, I have 17 years of working experience. So I graduated in 2004 with Bachelor of Engineering Honours in Civil Engineering. So upon graduation, I worked as engineer at the design office and spent a fair bit of time at the construction site as a site engineer. So after working for about 4 years, I continue my postgraduate degree at the University of National University of Singapore. So I was awarded the Doctor of Philosophy in Civil Engineering in 2012, and I stayed in NUS for about 3 years, working as a researcher and also a project engineer, a manager. So, and in 2015, I've decided to come back to my beloved hometown, Kuching, and currently I'm lecturing at the Swinburne Sarawak. At the same time, I'm also a civil engineering consultant as well as the independent consultant for my alma mater, National University of Singapore. So that's all about me. Being the first speaker, I think I'll just briefly go through what is engineering so that the subsequent speaker, they do not need to explain much on this. So the word engineering comes from Latin term ingenium, which means cleverness. And the word engineer originates from the Latin terms engineer, means to invent, to design, and to build and to make things work better. So basically, engineering is the practical application of all the sciences, maths, and combines. This is a combination of fields of science and maths to solve real-world problems that improve the world around us. Just give you an example here. So, civil engineer, we build buildings. Electronic engineers, they create mobile phones. Chemical engineers make paper, textiles, and mechanical engineers, they provide heating, air conditioning in the building. All right. So let's look at the 4 major engineering branches. So there are civil, chemical, electrical, and mechanical. And of course, there are many other areas of specialization, such as what Dr. Lai is going to present later, which is on the robotic and mechatronic engineering. So, and whichever the disciplines, so engineering is all about solving problems and process and analytical mind. All right. So I'll be covering topics on civil engineering and career as a civil engineer. So, civil engineering is everything that has been built around us, from 4,500-year-old Egyptian pyramids to 2,300 years old, the Great Wall of China, until today, the world tallest building we have today. Civil engineering has a very long and impressive history. So it encompasses a variety of sub-discipline and jobs. So if you take up civil engineering, you're basically you will be working as either structural engineers, environmental, water resources, geotechnical engineer, construction engineer, or transportation engineer. So civil engineering is actually focused on design, construction, maintenance, and the operation of a project. It can be a multi-story building, it can be a bridge project, tunnel project, water system, road and traffic system, and also a foundation project. All right. So let's look at the civil engineering marvels around us. So civil engineering is one of the oldest type of engineering. So if you look at the Three Gorges Dam is the largest dam in the world. Hong Kong Zhuhai Macau Bridge is the world's longest sea bridge, and this is quite is built in 1994. Kansai International Airport in Osaka, which is the world's first offshore airport that built on a completely man-made island. And of course, not forgetting our Petronas Twin Tower is Malaysia National's pride, which is tallest building in the world from 1998 to 2004, before it was surpassed by Taipei 101. So as a civil engineer, we involved in the construction and maintenance of all these public works, such as bridges, dams, the one that I mentioned just now, hospital, airports, and schools. Okay, just to give a few examples here. So let's go into sub-discipline of civil engineering. I think some of you here enroll for civil engineering programs. So basically, in your first year, you'll be taking common subjects. So soon you'll be going into the sub-discipline of civil engineering. So we have here structural engineering, we have geotechnical engineering, water resources engineering, transportation engineering, and just to name a few, we also have construction, environmental, coastal, material engineering, surveying, and remote sensing. Okay, so I'll go into the four major sub-discipline we have in civil engineering. So the first one is structural engineering. It's basically about calculation and understanding of forces, the strength of the building, the stability of the building. It can be a building or a bridge. So it's a very maths intensive, then there's a lot of physics involved. So the structural engineers will usually analyze and design a structure that will safely bear the estimated load of the structure that we design. All right. So let's go to the second one, geotechnical engineering. So it is a study of the behavior of the earth materials such as rocks or soils. So they also study ground improvement techniques. So a geotechnical engineer will involve in designing of foundation, slopes, retaining structures. It can be a tunnel projects, reclamation, or deep excavation project. Okay. So let's look at water resources engineering. So I'm a hydrologist. So I'm actually my expertise part under this water resources engineering. So as a water resources engineer, we design the system to manage human water resources. It can be a water treatment plant, a dam, a channel, a canals, and a pipeline systems. Okay. So we also study the development of techniques to prevent floods. We plan and maintain the facilities like we make canals for irrigations, seawall for drainage to avoid water logging, and also those water related projects to control the water. All right. So as a water resources engineer, we have to meet the water requirement of the society and the environment, such as the water resources engineer will build the water treatment plants and the pipe networks to convey the water from the treatment plant to the house tap, to the taps at the house, or they will actually do a sewer to convey the wastewater from the toilets of your house to the treatment unit. Right, so that's basically the role of the water resources engineer. Okay, let's go to the transportation engineering. So as a transport engineers, they plan, build, operate, and maintain system of transport in a way that it will provide a safe and efficient convenient movement of people and goods. So these are the project that involve in. It can be highway, airports, railway, public transportation systems. So as a transportation engineer, they study the new development. For example, if we have a new development, the transportation engineer will come in to study the impact of this development to the existing traffic. So they can either make improvement by adding additional lanes, or they can upgrade the current road conditions. So these are the roles of the transportation engineer. Okay, so probably you'll be asking, how do I become a civil engineer? So basically you are at the here. So you are now in your first year, so you can still enroll to other engineering discipline if you wish to in before probably in your second year, first semester. So now I believe some of you are from your SPM or STPM. So you have did your foundation study. So now you are basically here. So after completed the 4 years of engineering degree, you will have to work as an engineer. Of course, there are many other career opportunities. So if you were to choose to work as an engineer, so you need to go through training, at least 3 to 4 years of working experience. And if you choose to become a professional engineer or professional civil engineer, you have to go through exam and go through interview. And then these are the further specialization. If you probably, after working for 1 or 2 years, you want to focus on one subspecialties of civil engineering, like you want to become a structural engineer, a structural expert, or a geotechnical expert, then you can actually take out a master degree or advance even more by taking out the doctorate degree. Okay, so basically these are the route as an engineer. All right, so duties of civil engineers. As an engineers, so after you have graduated, these are some of the, I will just name a few, some of the duties as a civil engineer. So you have to provide technical advice to the client on your design, your construction, or even program modification. So you have to brief them. So you have to consider construction costs, This is also part of your role. So you have to know the government regulations. You have to know the potential environmental hazard that is going to occur if you were to design or you want to build a factory or, example, a building at that particular site. So these are the things that you have to consider before you start any project. Okay. So during the project's design or conceptualization stage, you will need to estimate the quantities and the cost of the project. So cost, it can be a material cost, equipment cost, or labor cost to determine the project feasibility. All right. Then if you happen to be at the site or if you happen to manage a site, then this will be your role to manage and direct the construction, operation, or maintenance of the project site. All right. And other than that, as an engineer or as a civil engineer, we also have to oversee and analyze the result from the test. Like, for example, soil testing. You need to know how to analyze it so that you can determine, you know, what type of strength to design for a foundation. All right. Other than soil testing, you will also have to know the test of the building materials. Building materials in this case means the concrete test, the asphalt test, and also probably the strength of the steel, the grade of the steel. So you have to know this. You have to understand the test for the building material for your project. All right. So as a civil engineer, or I would say as an engineer, you will also have to do public presentation. You have to present your finding. It can be a bid proposal to the client, or it can be an environmental impact presentation. So this is basically to give you some ideas. What is the duties of the civil engineer? All right. Okay, so it comes to the career opportunities. So after you have graduated, so there are plenty of career opportunities around. So I've quoted here. This is just to show the demand of engineers in our market currently. So this is not the latest one. It's 2018. So it says that Malaysia needs about 500,000 of scientists and engineers by 2020 to meet the challenges of the IR 4.0. So this is quoted 2018, but in 2018, we have only about 100,000 of registered engineers in the country. So this is probably not the latest also. So in February 2020, I've extracted this number from the Board of Engineers Malaysia, registered graduate engineer and also professional engineer. There stand about 140,000 of registered engineer. And out of this 140,000, there are about 48 or 50,000 of civil engineer. Okay, just for your info here, as an engineer, as a developed nation, we need about the engineer to population ratio is about 1 to 100. So in other words, for Malaysia population of 32 millions, we need about 300,000 of engineer to become a developed nation. All right, so here's are the career opportunities. Like I mentioned earlier, we have many sub-disciplines. So being a civil engineer, you can venture into a structural engineer. You can become a water resources engineer, or you can become the project manager, or even on your, you own your own consulting firm, become a consulting engineer. You can work for the research and development institution, and you can become academics. All right. So this is just a guideline on the graduate salaries in Malaysia. So basically, this is quoted from the JobStreet Malaysia 2019 report. So I believe the range is there won't be much difference within 1 or 2 years. So I couldn't get the 2020 salary report. So basically, the fresh graduate in Malaysia will get about 2000 to 2008. So 2008, the highest here being in 2019 being the graduates working in building and construction industry, whereas in engineering construction we also is quite high. It's about 2005. Okay, so this is just a guideline to give you an idea what will you be getting after you graduated from your degree program. All right. So probably you'll be asking, what if I don't want to become, employee? I want to become the employer. So I want to become the entrepreneur. So these are some of the examples here. So Business Insiders in their article mentioned that there are about 20% of the Fortune 500 CEO has an engineering degree. Okay, so these are the examples of the entrepreneur, a very successful entrepreneur who is also a trained civil engineer. Okay, so Huawei founder, Ren Zhengfei, he's a trained civil engineer. The Mexico wealthiest man, or one of the richest self-made billionaire in the world, he's also a trained civil engineer. And the famous Koch brothers, Walter and Thomas Koch, there were trans civil engineers. They are the largest as well estate developer in Hong Kong, and they also co-developed the Iron Orchard in Singapore. So these are some of the examples for successful entrepreneur outside Malaysia. So let's look at the successful entrepreneur in Malaysia, who is also a trans civil engineer. So we have Tan Sri, Dr. Francis Yeo, the managing director of YTL Group of Companies. Okay, we have the group managing director of Gamuda Berhad, Datuk Lee Yunin. He's also a trans civil engineer. And this is the example of notable civil engineer in Malaysia, which is our Minister of Transport, Dato Sri IR Dr. Wee Ka Siong. So his PhD is in transportation engineering. All right, so he's also the president of MCA. All right, so I think come to the end. So probably some of you will be asking what will be the demand, the civil engineering or even engineering professions demand in the post-COVID era, 19 era. So basically, yeah, of course, there will be a short-term impact on the job requirements or demands, but this will only be temporary. So do not worry, you're in a correct discipline. You're in the right field, so you have enrolled at these engineering degree programs. So because this will be just a temporary, and engineering will still be in high demand in the post-COVID-19 world. Okay, but of course you have to equip yourself with some of the because we're going to lead the way towards IR 4.0. So you have to equip yourself with some digital software and put it into working practices. So the conventional, what we did conventionally will soon replaced by the digital software. So what you need to do now throughout your 4-year study in Swinburne, get yourself equipped with all the modern software to lead the IR 4.0. Okay, so I think that's it from me, and thank you for having me today and inviting me. Any questions, we will put it during Q&A lah, Jawi? Are we going to have a Q&A session later on?
Yes, sure. There will be a Q&A session at the very end.
Okay, then I think I'll just pass back the mic to you.
Okay, thank you, Dr. Angela, for your informative sharing. So now let's hand it over to Dr. Lai, who will be sharing on robotics and mechatronics engineering. Please, Dr. Lai.
Okay, thank you. Let me share my screen. Right, can you guys see my screen?
Yep. Yes, it's visible.
Okay.
Yes, we can.
Right, hello everyone, good morning. So my name is Lai. I'm the discipline leader for robotics and mechatronics programs. And just a bit of introduction to myself. I have been teaching into robotics and mechatronics courses since 2010, right? So about 10 years of experience in teaching into robotics and mechatronics courses. Okay, so and yeah, I'm also one of the graduates from Swinburne, right, in these robotics and mechatronics programs. Okay, 8 years ago. So just to give you an introduction about what is robotics and mechatronics. So it basically comes from two terms. One is robotics, which I believe most of you have some ideas about robotics, and maybe not so clear about what a mechatronics actually means. So mechatronics is not a discipline by itself. It is an interdisciplinary branch of engineering that consists of electrical electronics engineering, mechanical engineering, and product design, sensors and actuators, computer system and software engineering, and then control theory and system engineering. Okay, so if you look at the diagram here, mechatronics is basically a combination of all these engineering disciplines and an integration between them. Okay, so if you want me to give you one single word that describe mechatronics, then it will be automations. All right, so if you think about anything that is automated, right? It works by itself. It can work smartly, intelligently. Then you can classify them as mechatronic systems. Okay, so just now Dr. Angelia mentioned that engineers make things work, right? So robotics and mechatronics engineers make things work smarter. Okay, so this term mechatronics is actually originated from a Japanese company in 1971. So it is a relatively new branch of engineering. And in that time, the definitions of mechatronic basically just describe a system that is an integration between mechanical systems and electronic systems, plus some computer software to make it automated, right? To make it automated. But as the technology advances so quickly nowadays, and the complexity of the systems actually continues to evolve. Okay, so the definition of mechatronics has been broadened to include more modern technologies such as cyber physical systems, Internet of Things, sustainable technologies, advanced robotics, or any kind of smart and intelligent systems out there. Okay, and many more, you name it. As long as they are automated, they perform job smartly, then you can classify them as mechatronics. Okay, so what about robotics? Robotics is actually a subset of mechatronic systems that usually resemble the mechanics and motions of humans or any living things. Okay, so I give you some examples here. On the left, we have humanoid robots and the bio-inspired robots, right, such as the spider, lizards, or dogs, right? And why engineers is trying very hard to mimic the mechanics or the mechanisms of these animals is because some insects also is because these insects or animals, they have a mechanism that is so efficient that most of the machine cannot perform, right? Cannot produce. So they're trying hard to make all the mechanism works more efficiently, more smartly, and consume less energy. Okay, so but all these kind of robot, the one on the left, they are most of them are in developmental stages, right? Not much of applications out there. So what we are really targeting, what we learn, the application of it is actually the one in the right? So we have the industrial robots, okay, that you can see in the manufacturing plants, and also mobile robots. It could be on the ground, it could be a drone, or it could be a robot underwater. Okay, so I just give you some example here. The first one is the Mars rover, Curiosity, and then some mobile robots that is working in a warehouse. All right, so in the logistic industries. Okay, so when it comes to sub-disciplines, I won't say sub-discipline, but it's basically other disciplines, right? But we try to integrate them. So the first one is about mechanical engineering. So in robotics and mechatronics, we learn about the mechanics and the dynamics of structures, right? And then we learn machine designs, how you design machine components, and 3D modeling, how you produce 3D models of your products or of your mechanism, things like that, and also a little bit on material science. Okay, we want to know what material is good to be used for different applications. Okay, and the next one is, of course, the electronics engineering. So you will learn about circuit, you will learn about semiconductor, digital electronics, microcontroller, sensor, actuators, and also signal processing. Okay, signal processing or some machine vision, for example. And then you will learn about software. You learn programming, you learn how to develop software, and most importantly, you will learn about embedded system programming, right? Whereby you will program some physical things to be working. Okay, and then we will also learn about control engineering. This is a very important part of mechatronic systems because we want the system to move in the way that we like. Okay, so we need some kind of controls, right? So in the course, you will learn about control and automations, robotic controls. Okay, but next thing is about system engineering and engineering design, because we are an interdisciplinary branch. We integrate things. So we'll learn about how to design robots, design mechatronic systems, how to conduct research projects, and also you will learn about some soft skill in project management. Okay, and lastly, we will have what we call an Industry 4.0 elective, where you will be learning, you have a chance to learn about some of the core technologies in Industry 4.0, right, such as Internet of Things, data science, AI, and also web application development. Okay, so I think what you are you want to know more is where you will be in the next, say, 3 to 4 years time, right, after you graduated. So of course it's very obvious that all the manufacturing plants, right, industrial automations or industrial robotics. Okay, so I think most of the industrial nowadays are already automated, so you will find a job in any types of manufacturing industries. Okay, and it could be in the logistic, right, whereby robotics are nowadays used in warehouses, automotive industry. So nowadays sensors, many sensors are already installed in the car. So when you go to maintenance, they basically just download all the data from the sensors, and they can try to predict what is the failures and things like that. Okay, so it could be in the healthcare industry, where biomedical engineering, so, and then software engineering, right, software engineering. And just to mention that this is the big areas, I mean, in the futures, smart system integrations. So it's very hard to categorize what is smart systems. Basically, in every sectors, right? It's nowadays it's in every sectors. It is energy, we call it smart energy. Farming, we call it smart farming. Smart city, and then in the smart city you have smart parking, you have smart shopping malls, or anything. All right, that can be automated. So you will be a system integrator. You can be a system integrator after you graduate. For example, you can design something, integrate systems to make your farm into a smart farming, right? Things like that. So these are some of the insight of where you will be in the next 3 to 4 years or 5 years times. Okay. And I think before I end the presentation, just want to introduce to you these Industry 4.0 things. So it's basically a digital transformations, the current trends of automations of traditional manufacturing process and any other industry practice. All right. As I mentioned, this digital transformation is happening in almost all sectors, especially in this COVID times. It is actually accelerated. All right, accelerated. So if you look at the diagram here, there are nine core technology, or the pillars of Industry 4.0. So starting from the 12 o'clock position, you have cybersecurity, augmented reality, big data. So these are ICT, right? These are computer science things. But if you look at number 4, is robots, right? Robotics, additive manufacturing, right? Like 3D printing, right? Which is also a types of automations. And then simulations, system integrations, right? This is a big part, system integration. So all the smart systems is under these system integrations. Okay, and cloud computing, of course, is again ICT and Internet of Things. So if you look at this diagram here, I think half of them are quite related to robotics and mechatronics. All right. So at Swinburne, we have our School of Engineering, which offer 2-degree program. One is the single degree, which is the robotics and mechatronics program. So if you look at this diagram here, you will learn some core engineering courses plus some robotics and mechatronics specialist course, and then you have a chance to select Industry 4.0 courses, right? Just like what I mentioned to you just now, plus some industrial placements, okay? And the total period of study is 4 years. And we do also have a double degree that is including the robotics and mechatronics and computer science. Okay, so at the end, okay, this program takes 5 years, and you will obtain a Bachelor of Engineering in Robotics and also a Bachelor of Computer Science, right? Where in computer science you can choose from these 5 majors. All right, so I think if you look at my previous slide about Industry 4.0, much related, right? They are very relevant. Okay, so just okay, this is my last slide, I believe. So in robotics and mechatronics program, we focus on industrial how to say it, industrial based projects. Okay, we want to solve real problems in the industries. So here some image on the left here are some of the example of projects that our staff and students doing. Yes, and then on the right we have very good records of student winning competitions. Okay. All right. So I think that's it from me. Thank you. I'll pass back to Jiaowei.
Thank you, Dr. Lai, so for your insightful sharing. So now let's move on to Dr. Victor, who will be sharing on mechanical engineering. Please, Dr. Victor.
All right, hi everyone. Okay, you guys can hear me, right?
Yeah.
Okay, if it's too soft, you let me know. Okay, I will share my slides. Okay, is everyone looking at the slides now?
Yep.
Okay, all right. So thanks, Jerry, and I think good morning, everyone. Good day, everyone. I know it's almost lunchtime now, so I would try to go as fast as I can. And thanks to Dr. Angela and also Dr. Lai for the good presentation on the overview of engineering and also all the different things about civil engineering and also robotics and mechatronics engineering. So I'll just stick to mechanical engineering in my presentation later. So my name is Victor. So I'm also currently lecturing in Swinburne, Sarawak, and my major is in mechanical engineering. So I actually graduated, let me see, 11 years ago from my first engineering degree. And later I spent few years working in the industry, mainly in the HVAC related industry field, before I rejoined Swinburne to do my PhD. And after that, I joined the academic team. So basically, that's a little bit about me. So I think all this has been gone through who are engineers, but I'll just briefly touch and go. So engineers, remember, we are all problem solvers. So if you are taking engineering, I imagine that all of you must also love problems and finding solutions to problems. So some examples in the history, such as this human-powered crane on the left-hand side. Okay, because there is a problem to build buildings, you need to do high-rise buildings. So that's why we came up with a solution for human-powered cranes. And also the Wright brothers came up with airplanes because, well, we dream to fly, right? So engineers are basically problem solvers. Just keep in mind that. So don't be afraid of problems in your 4 years of study. Now, just to add on a little bit to that, engineers are actually creative and collaborative problem solvers. That's why you see that you will learn to work in teams along your 4 years degree journey, because at the end of the day, when you start working, you will be working in a team, and most likely multidisciplinary teams. Okay, I purposely put this comic strip here because it shows you that how many different engineering can be involved in just a car. Okay, a car breaks down, a mechanical engineering definitely will think that it's an engine problem, okay, because the engine won't start. But a chemical engineer, if you have a chemical engineer in the team, they may think that it's the fuel problem. Maybe it's the wrong fuel, maybe the fuel is dirty, or the gas is contaminated, or something else. If there's an electrical engineer, they may find another perspective to the problem. They may think that it's a grounding problem or grounding issue. And if you pass it to the software engineer, they may think that it's the system in the car or the electronics in the car, maybe your ECU or something else is wrong. So you can hit a reset button and everything might work again. Well, this is just different perspectives from the different engineering fields. So remember, engineers are problem solvers, but we are also creative and we work in teams, all right? So coming back to the main topic, who are mechanical engineers? Okay, this is a good comic strip that gives you a brief idea what a mechanical engineering about. Basically, we deal with anything that moves. Okay, so for example, your cars, your trucks, your traffic, your ships, your airplanes, or if we strip it down into smaller things, it's the mechanism that allows any kind of movement. So we deal with all the kinematics, all your mechanisms that's assembled together into machines. Okay, so this is what mechanical engineering is about. So some of the common perceptions when we talk about mechanical engineering that some of you may have could be building space shuttle, as I mentioned, is still something that moves. Building airplanes, okay, building ships. Or some of you may think about the oil and gas platforms. Yes, it's also correct. It involves mechanical engineering as well for all the different structural component and also all the different services, pipelines, for example. All these are related to mechanical engineering. Now, another one, of course, cars, F1s, and something that most of you may not be relating to is actually air conditioning. Okay, it can be as big as a district cooling system. Okay, it can be as small as the split unit air conditioning in the room. Okay, apologies for the background noise. So basically, mechanical engineers research, design, develop, build, and test any kind of mechanical and thermal devices, including any kinds of tools, engines, and also machines. Now, mechanical devices can be any type of engines. The other one, thermal devices, is probably not as common to most people. There is anything related to heat transfer. Actually, mechanical engineers also deal with this. Okay, heat and mass transfer is one of the major fields in mechanical engineering. So mechanical engineering engineers basically analyze problems to see how any kind of mechanical and thermal devices may help to solve any kind of problems. Okay, mechanical devices is like a car engine. Okay, your compressors, okay, compressors for your aircon, for example, that's basically a mechanical device as well. It can be a thermal device. Okay, so all this is about how we as mechanical engineers make use of this to help solve problems. So for example, again, air conditioning, what problem does it solve? It provides cool air for us, especially on a hot day like today. So then if we look at mechanical engineering, it is basically a discipline that applies the engineering physics, maths, and material science principles to design, analyze, manufacture, and maintain any kind of mechanical systems. So together with civil engineering as well, it is one of the oldest and broadest of all the engineering disciplines. So if you look at the sub-disciplines of mechanical engineering, you could be looking at manufacturing field, the thermal engineering field, automotive, acoustical, which deals with vibrations and also sounds, because basically sounds is also a a form of wave, so it involves vibration as well. We are also looking at aerospace, as you see the space shuttle earlier. Naval, there is your ships, biomedical, structural, and there are still other subdisciplines which I didn't list over here. So just in short again, mechanical engineers, basically we mechanize the world, we move the world, we deal with machines. Okay, so it can be something as big or as complicated as all these mechanisms or components, or it can be any kind of machining tools, or it can be something more advanced like a jet engine that involves not only forces, energy, it also involves combustion. Or it can be something as small as, can you guess what is this? It's actually a mechanical watch. Okay, it can be all the mechanisms inside that is also related to mechanical engineering. So let's take a look at the mechanical engineering marvel. So like I said, you can be designing mega big stuff like the one on the bottom left that is actually bigger to it. It is actually a giant vehicle of land used in mining, and it can be also an aircraft carrier. Okay, USS George. This is by the US, so mechanical engineers can also be involved in design of this kind of aircraft carriers. Or on the other hand, we can be dealing with something as small as atom sized. Okay, so this one you are looking at the nano engine on the top left. Okay, it is an engine that works on a single atom. So basically for mechanical engineers, you can be involved in something really big into something as small as one single atom. Or even if you are interested, you can go into nanoscale heat transfer. Basically, that was what I did for my PhD before. And you can even venture into quantum physics if you are good in physics after. All right, so these are just some of the possibilities. Now, again, as mentioned before, mechanical engineering is a very broad field. So I have listed here some of the areas of interest. Now, during your 4-year degree study in mechanical engineering, you are basically covering all the basics and all the components of mechanical engineering, which makes it essential for you to actually join any areas of interest listed over here. So I'll just briefly go through one by one. So the first one is, of course, biomedical and engineering fluid mechanics. So this is all based on fundamentals of fluid mechanics and their broad range of applications in the biomedical and engineering arenas. So biomedical engineering, you can think about dealing with the blood flow or fluid flow within your body. So you can be looking at artificial hearts or even prosthetics, or you can go into engineering fluid mechanics, such as pumping systems or wind turbine design. But all this requires you to have very good fundamentals in engineering fluid mechanics. A second area of interest is combustion. Okay, combustion, usually we deal with the environment as well, because the byproducts of any combustion can potentially cause pollution to the environment. So as mechanical engineers, we design combustion systems like internal combustion engines, the ones you use in your car, or any gas turbines or furnaces that is used for energy generation. But we have to think about ways to make this a cleaner alternative, and also how to make it environmental friendly and reduce the pollution we cause to the environment. So in this case, you need to be very good in your thermodynamics and also any kind of heat and mass transfer. Another one possibility would be your ground vehicle systems. So you can deal with any kind of automotive designs, any kind of transportation vehicles design. And that also includes looking for alternative energy source to drive these vehicle systems. Another field that you may look at is heat transfer, thermodynamics, and energy systems. So this can deal with power generation. It may also be dealing with, as I mentioned before, your air conditioning systems. Okay, this is the schematic on the left here is actually the air conditioning system similar to what we have in the university and in any commercial buildings. So it's not just basic split units that you have in your room, but rather it's huge units. It can go as big as what we call district cooling, where you have a centralized plant that is actually supplying cold water and cold air to several buildings around it, such as the one in KLCC and also in Putrajaya. So those are considered bigger systems. Another field that you may join would be manufacturing. Okay, you may be dealing with the manufacturing process, or you may be dealing with designing the mechanisms or the machines that is required for manufacturing. And of course, mechanical design, to design any system components, to design pumps or any kind of mechanical systems. You can also be involved in system dynamics or control, as Dr. Lai presented earlier in mechatronics. A lot of it is about automation, but for system dynamics such as vibrations, such as building management system, especially for HVAC, you also need knowledge of mechanical engineering. Now, last one, of course, is the transportation system. You may be looking at train systems or any kind of transit systems. Okay, so this you may be involved in planning, design, operation of these systems, and you will also need the mechanical engineering knowledge. Another aspect that you may be looking at would be the maintenance of these transportation systems. So let's move on to the careers. So you know that there are so many different types of fields or areas of interest in mechanical engineering. So what are the careers that is involved? You may be a mechanical engineer. Okay, you may be also a transport engineer, manufacturing, construction or process engineers for various companies. You may also be involved in research and development organizations, or maybe rejoin the university doing research. You may also be doing consultancies. Okay, one of the most common consultancies that mechanical engineers will be involved in is actually building services. You may also be joining utilities companies. Okay, for example, power generation. You may also be joining government, armed forces, or any or as a sales engineer. Okay, these are all the possibilities. So I'll give you some example of roles as mechanical engineer. You may be involved in designing. So in this case, you will need additional skills in computer-aided engineering, which you will also learn in your degree. You may be involved in production, maintenance, okay, or sales, or in terms of planning. Or as Dr. Angela mentioned earlier, you may also embark on entrepreneurship. Now, there's one saying that one of the benefits of doing engineering is actually you can end up as an engineer, you may also end up as a businessman. Okay, but it's not as easy if you go to business first and then you try to become an engineer. Right? It's usually the other way around is easier. Okay, so coming back to this, linking all this back to your study, what you need to do right now, you need to make sure that you have a strong foundation in physics and mathematics. Okay, and along the way, you will be more specialized depending on which area of interest you have. But basically, in your degree years, you will still be learning all these material and manufacturing science, thermodynamics and heat transfer, fluid mechanics, machine dynamics, control systems, static analysis, and also engineering management. But of course, once you have decided to specialize into something, then you will be going in depth in certain fields later. Okay, so next thing is a question that most students usually have: do I have what it takes? Think about all this. This is all the qualities that you need to be a good engineer in the future. So you need to have the technical skills. You need to have the ability to work under pressure. Somehow engineers, I don't know why, are always famous for being last minute. I hope you guys will change that in the future with better planning. And you need to have problem solving skills. You have creativity. You need to have good interpersonal skills, communication skills, commercial awareness, and also team working skills. And most importantly, actually, is you have to ask yourself this: do you have the passion or interest in engineering? Because you will be doing this for the rest of your life after you graduate, unless you decide to go into something else later. All right, passion is one of the most, or one of the key ingredients, I would say, to be a successful engineer in the future. So again, bear in mind that engineering is getting increasingly multidisciplinary, so make sure you learn how to work in teams of different people, personality, cultural background, and also different skill sets. So some of the notable people, I think I'll leave this to you. You can always go to Google to check out who are the famous mechanical engineers. So one last piece of advice before I end my presentation is that to always remember this: tomorrow's engineers cannot solve tomorrow's problems with yesterday's thinking. It is always a good benchmark to have yesterday's thinking as a reference, but you always need to improve to be more creative, because problems are constantly evolving, okay, especially problems that matter, and we always need to find more creative and better ways to solve them. All right, so that's all I have. I'll pass it back to Jiawei. Thank you.
Thank you, Dr. Victor, for your enlightening sharing. So now, let me share my screen. Can I share? Why can't I share? Hold on a second. I don't think I have the access to share the link.
Hi, Jawed. Hang on, let me sort it out for you.
Okay, so while we're waiting, I guess we could have the questions first, since time is running.
Okay, so students, if you have any questions, you can post it into the chat. Jawed, you may try to log out and log in again and see if you can do the screen sharing.
Okay, sure.
Yep.
Yeah, I can share now.
Okay. We don't have any questions. I think Ryan did post a question there. Yeah, if you do have any questions, students, you can always forward it to me as well, and I can forward to the IEM student section. So hand over to you, Jiawei.
Okay, thank you, Mr. Anderson. Where am I now? So can everyone see my screen?
Yeah.
Right, so to start off, what is IEM-SSSS? IEM-SSSS stands for the Institution of Engineers Malaysia, Swinburne Sarawak Student Section. And IEM is a professional club and this club is a professional club for all engineering students in Swinburne University, Sarawak. Okay, then this is a video, but due to time constraints, I'll send the link to the video in the chat. Javier will help me send the link to the chat, and so let's skip that for now. Okay, so what are the benefits of joining IEM-SSSS? By joining, you get to connect with your respective peers because IEM-SSSS acts as a medium for you to get in touch with engineers from other types. So maybe you could get to know an electrical engineer, another chemical engineer, even though you're just a mechanical engineer, stuff like that. So also, it could help you nurture relationships with professional engineers because you could get in touch with them. IEM-SSSS is also a medium for you to develop your career with discounted or even free access to IEM events. Also, by joining IEM-SSSS, you could boost your resume and also gain useful skills through events. So here are some of the past activities that we have. So we have had technical talks and workshops. The screenshot on the left is a CIDB green card course. Also, we have had talks on the power of AI, AutoCAD workshops, and many more. These are just some of the examples. Also, we had site visits, Mini Science Expo 2019. The 2021 was postponed due to COVID-19. And then we also had team building trips. This one was a committee bonding session with IEM from Unimas, IEM Safe from Unimas. And this was the secondary school sharing session and Kahoot quiz that was held earlier this semester. Also, we have had collaborative events with ASHRAE, SSSS, where we are introducing what ASHRAE stands for and HVAC. And for updates on our upcoming events, you could visit this website over here. So then from here, you could get some updates on our confirmed events. And also, Javier will be sending the link into the chat. You could also follow us on Facebook or Instagram to get updates on our new events. So some of the upcoming collaborative events are Route to be a Professional Engineer and Professional Technologist, which is held in collaboration with TAM-SSSS. The date will be on 7th of April, 3 to 4:30 p.m. on Microsoft Teams. Industrial Recruitment Talk by Intel Technology, which is in collaboration with SSIET. Then another one would be the beach cleanup, but it's also postponed due to COVID-19. So yeah, we will give you further updates on that. Currently, there are still 2 empty slots, so you could contact us to register for this. And here's a list of all the upcoming events for IEM. So we have a talk on how to prepare yourself for IR 4.0, talk on hydrogen production plant and refueling station, SolidWorks workshop, internship preparation, CIDB talk on route to be this was what I just introduced just now, recruitment talk by Intel, blood donation drive, gaming night, and also beach cleanup, which is still tentative. For how to join us, you could go visit this website. Similarly, Javier will be sending it in the chat. Then once you're here, you click on club registration. And you could follow all the steps listed here. So as you can see over here, there will be a form at the bottom here, which you will need to download and fill. After that, you scan it and submit it through this Google form. Please be reminded that the membership price is a one-time payment, so you just need to pay once and then you will stay an IEM-SSSS member until you graduate. Also, for more information, you could also contact Jake Chiang via WhatsApp. Similarly, we would post his number on the chat. And yeah, that ends my session. Any questions?
I do have a question. So we do have some international students here. Are they also welcome to join? And how would they benefit from this from an international student point of view?
For international students' point of view, it also helps you boost your soft skills. And because you get to know more people, you get a chance to host events. And you can get to know more people.
Thanks.
So, yeah.
Okay, so I think I will also share the links to the registration to my Canvas unit. So then those that are interested can get the links and the details from there. Okay, Jiawei, are you still there?
Yeah, I'm still here.
Yeah. So is that all? Okay.
Yeah, that's all from me. So if there aren't any more questions, this would mark the end of this session.
Yeah, thanks very much to the IEM student section. Jiawei is here. Actually, all the students from those IEM student section were taking this unit many years ago, either from 2019 or even from 2020. So very interested to see, like maybe some of you will be also taking up these duties in the future, and welcome back again in the future for promoting this club or student section to the new batch of students in the future. Yeah, so thanks very much also to our lecturers, Dr. Angelia, Dr. Lai, and Dr. Victor for their presentations this morning. Okay, so that's the end. Thanks very much, everyone. I'll see you guys again next time.
Thank you. Bye-bye.
Thank you.
Thank you, Dr. Victor, Dr. Lai, and Dr. Angelia. Bye-bye.